Hello everyone, welcome back. Today we are going to see different concepts in the machine learning like gradient descent, how we can implement a machine learning algorithm without the sklearn using the gradient descent, and then we can see how we can handle the missing values and different concepts. Okay, like how to get the dummy variables, one hot encoding and label encoder, and different type of errors. We can see different type of errors like mean square error, mean absolute error. All these things we are going to see. One more thing, how we can use a model that we already created. We can save the model and we can reuse the model. So agenda for today's class is we are going to cover certain basic things about the machine learning. Okay, am I audible guys? Clear? Shall we start? Yeah, we will try all the concepts practically. We will see all the concepts practically in today's class. So in the last class we already implemented one example of simple linear regression that most of you already know. What we have done in that example, just give me a recap. Okay, so in this example, what we have done, we first imported all the necessary libraries and then we imported data set. What the data set we are going to use here, the salary data, and then you can see here in the salary data we were having only two columns. One is years of experience, another is salary. Years of experience and salary. So we are having only two columns. This is the linear regression, simple linear regression example. Yes, salary is based on years of experience. Now more things we will do in this example. We will save our model, we will see its accuracy, its score, and certain parameters, how we can implement some examples with the help of gradient descent. And what is the gradient descent? These are the things we are going to see. So we have loaded this data set, then different properties, statistic properties. After that we have moved towards the how you can visualize the data using the scatter plot. Okay, and then we divided data into two parts, training and testing. After that we have created a linear model with the help of sklearn library. Okay, and when you created your own model, you can make certain predictions. Okay, so prediction part also we have checked, but now some things are remaining, like how to check the error, accuracy, and what is the cost function. All these things, all these things we are going to see. Okay. So guys, clear? Now the first thing comes to our mind is what is basically gradient descent and how we can do the things without using this sklearn. Like I can tell you one thing. Okay. In the linear regression, we are having a algorithm. We are having simple, like first we will see simple math, like we are having some values, x equals to 1, 2, 3, 4 and 5. Okay, as input. And in the mathematics, if I apply an equation like this, y is equal to 5x plus 4. Okay, y equals to 5x plus 4, then I'll get y values equals to something like I'll multiply, I'll put the x value in place of this variable and then get the value of y like 1, then you will get the value of y is 9. Similarly, you will get the y values different like 9, 14, 19 and then 24 and then you can say 29, something like this. Okay, so we derive y value from x value. And using this equation, in simple maths, we are doing these things. Now I'll relate these things with the machine learning. In the machine learning, what we are having data in form of input or output. We are having input and output. Input we generally represent in the simple linear regression x, or if you are having multiple variable, you can say x1, x2, x3 like this. And output is y. Okay? Input is x and output is y. So here we are having input and output, and on the basis of this we need to derive a equation. Okay? We need to derive an equation. That equation you can say a algorithm. Equation is basically a algorithm. Like in the case of salaries, we are having years of experience. So you can say experience in the form of an array input, and salary is your output. Okay? And what you are going to get? You are going to get an equation like this: salary, and salary equals to 135, some constant, coefficients you can say, some values, like in the last example, what the values we got for the coefficient, you can check here. These are the value. The equation which I have made for this is this equation. Let me copy this. Okay? I'll increase text size, don't worry. Something what I just want to tell you here, X is experience. Experience. So we are getting some values. How we are getting these values? Okay, so we are getting this list, this equation. So in this equation, C is here M is a constant, you can say slop, and C is a constant. We are making an equation, but how we are making this equation? How we are creating this equation with the help of sklearn? I just want to tell you the math behind this equation, how this equation sklearn interprets, how we can create this equation without using the sklearn library. Okay? So for this we use gradient descent. Let me explain you here. This would be more better. Okay? Okay guys? Yeah. Now I'll tell you one more time how we can derive this equation. Like we are having two things, experience and salary. Okay, and your experience is X, you can say input, and salary is your output Y, or label. Input is called feature, and we are creating an equation like this. At the end, salary equals to some constant, like here I am putting some random value, 135 into experience plus 138 something. Okay, so how we can derive this equation on the given input and output? You can see in the data we plotted a graph like this. There we are having some salary and we are having experience. Okay, so we are having certain points like this. And linear regression model provided you a line. This line is what? This line is basically this equation. This line is basically this equation. We are getting this line with the help of this equation. We are putting different values of experience and it will predict salary accordingly. So how you can get this line? This line is best fit line. Best fit line. How you can get the best fit line? There can be many lines, like I can draw some line like this, I can draw some line like this. There can be different lines. So which line is optimized line? How we can get the best line? For this, what we are doing, basically, we can check like this, okay, and our regression line is like this, or we are having points, some point here, some points here, some points here, some points here. Now what we will check the difference, like input is here, experience, and corresponding salary should be here. But our model is telling salary is here, like salary is this. So what is the difference? You can see this is the difference. You can say delta. Similarly, for every data point we are getting some difference. This is the difference. This is the difference. This is the difference. And this is the difference. What is the difference? Difference here, you can say this is the original value and this is the predicted value. Okay, we are having original value and predicted value. We will check the difference between predicted value and original value. Predicted minus actual value. And what we will do? We will make its a square. And then we will do summation. Summation is I is equal to 1 to n. And then we will divide this by n. This is basically called mean square error. Mean square error. Here we are taking predicted minus actual, it's a square, and for every data point, like this is first data point, this is second data point, and this is third, okay, and this is fourth, and this is fifth data point. So we need to sum for all of them the difference. And why we are taking the square? Because if it is a negative, it skewed our result. So that's why we are taking here the square and then sum of all the square and divide by n. This is the formula for mean square error, and we also call this cost function. Okay. So cost function, this is basically cost function, or you can say this is error. We call it error. Clear? And now come to the second thing is, what is the gradient? How we can minimize? We want to get the best line, best fit line. Best fit line is to minimize this error, to minimize this cost function. Okay, so for minimizing this error, what we can do? You can write the formula like this. Mean square error MSC. Okay, mean square error equals to 1 divided by n, and then summation of I equals to 1 to n and y of I minus y of predicted, and it's a square. This is basically formula. Now if I talk about the gradient, okay, who will do this part? Basically gradient is a algorithm, and this algorithm finds best fit line. Best fit line for given training data set. How? Now question comes to mind is how gradient is getting the best fit line. Basically, if you see gradient thing, in the gradient, a graph is, we are making a graph between mean square error and constant thing. What the constant thing we are having in the line equation? In the line equation, y is equal to ax plus b. Okay, this is the slope and this is the intercept. So here we are having two things constant. A is, these two constants we can change. So mean square error, we will plot the mean square error with respect to A and mean square error with respect to B. And if you see, graph of mean square error is something like this. Always. Okay, mean square error is also called cost. So basically what happens when this constant value is less, error is more. Similarly, when constant value we are increasing, error is decreasing, and at certain point error is minimum. You can say this is minima. And again after that, if we increase the value of A, error will increase. Similarly for the B also. So now how we can get this thing? We can go by certain steps. Okay? We can take certain steps. We need to find out this global minima. Okay? So little bit math thing we need here. Basically, we need to find out the slope. Slope for this to going in a direction. Like here, if I'll see the slope is like this. If I'll go, slope is like this. It will give you the direction. Slope will give you direction. So what does the slope mean here? I'll take the partial derivative of MSC with respect to A, or partial derivative of MSC with respect to B. Slope is basically this. And steps can be less and more. Are you getting the what is the slope? Yes, just wait, I'll tell you each and every case. Okay? Basically, this will give you, slope will give you direction only. Now, how much, like steps, by what value I can change? Okay? Cost is basically error. Cost is basically error. Again, I'm telling you, cost is error. Difference between how far are predicted result from the actual result. Okay? Don't confuse. This is the simple thing. We are creating a slope. Again, I'll tell you, we are making a slop. Let me try again to tell you. This is this, and here a graph, and we are taking certain steps like this. Okay, and basically we just want to, slop will give you the direction. Okay, slop will give you the direction. You just want to get local minima. Slop is basically, I can say slop is change in y with respect to x. Here x, here y, here experience, or here salary. Sorry, it's not experience salary. It's a basically a and its y is salary. Mean square error. MSC. Okay. So I just want to get the derivative, like I'm having some mathematical function x square plus y square. Partial derivative of this f of xy. Partial derivative of delta of f with respect to x is 2x. And partial derivative of f of with y is 2y. Or either I can write here cube, then 3y square. Okay. So this is the partial derivative. You can see the math thing. We can calculate the partial derivative like this, and partial derivative here will give you the slop. And slop means we will get the direction. And like steps, we can take the steps. Steps we can take bigger or smaller. Like if I'll take the bigger steps, then I can skip this local minima. Okay, and very small, then it never converts. So we need to take care of step, and here step is basically represents, step is learning rate. Okay, step is basically learning rate. And in mean square error, we will write the equation like this: MSC equals to 1 of n sigma I equals to 1 to n y of I minus Am I audible? Yeah, just refresh your page. Don't worry, it's working fine. Okay, so what I was telling you, basically we are writing here. This is just because of the whiteboard, because whiteboard taking lots of things. It's a runtime connecting, so that's why it's taking lots of things. Let me write again equation. Or I'll take a fresh one. Okay. So here I'll write MSC 1 by n, and then you can write summation of I equals to 1 to n, and then in the bracket you can write y of I minus and ax plus b. This is basically our equation. Here I'll write partial derivative of MSC with respect to a and partial derivative of MSC with respect to b. Okay? No, this is attendance format is we have provided you in the pin message. You can check by the Go Code Hub only. So you can see that, nothing else. Okay? So simple, you need to write your registration ID or name, no phone number, no email ID, nothing else. Okay? So here we need to take basically partial derivative of with respect to A and with respect to B. So with respect to A, if you write here, this is square also. So 2 by n, I'll write here 2 by n, and then I can write summation I equals to 1 to n and then minus x of I with respect to A. X of I and y of I minus axi plus b. Okay? This is the simple. You can do the partial derivative. This is math thing. And similar thing, I'll write for this 2 by n with respect to b. With respect to b is simply summation I equals to 1 to n, and then I can write minus y of I minus a of xi plus b. Okay? These two equations we will get with the help of partial derivative, and these are our slop. Now we will see the learning rate. How we will calculate the learning rate. Okay? Learning rate is basically okay? Let me tell you with respect to A. Okay? If with respect to A, this is some old A1 and this is A2. Okay? A1 and new is A2. I need to calculate this A2. How I will calculate A2? A2 is A1 minus learning rate into partial derivative of mean square error with respect to A. This is new value of A2. Similar thing I will do with the B also. Okay? Getting the things? Basically, this curve is equation. Somebody is asking why we are using this curve. This curve is basically curve with respect to mean square error and constants, MSC. You can check for any algorithm, mean square error with respect to coefficients, always it will give you the curve like this. This is the standard curve. This is not your linear regression curve. Okay? So basically mean square error and then this constant. Now what we are in this equation, simple equation, like what we can update in the line equation, y is equal to ax plus b. X is fixed and y we need to predict. So what we can change? We can change value of a and b. We can change value of a and b. Initially we are taking random values for a and b. Okay, and then how we can update the new values for A and B? We can update the new values like this. Like new value for A is old value minus learning rate into derivative of mean square error with respect to A. Got it, guys? What is the new value for A and what is the new value for B? New value for B is also same, old value minus learning rate into derivative of mean square error with respect to B. This is the math thing. I can show you this thing in the implementation part also. Can you please tell me in the chat window, everything is clear till now? Yeah, learning rate is something fixed value. We can give a different try, like maximum people using starting from 0, 0, 1. We can change this value and we need to check out the different permutations. We don't take very big value and we never take very small value. We will take certain standard values like 0.001 or 0.01. Yeah, how we use this in ML, I'll show you one practical. Basically, these things who will do for us? Gradient. Or basically, these things in the sklearn automatically happens. You don't need to do. Okay? So, let me explain you these things in the coding part. One thing you should remember, what we are doing here, one more time I'll conclude the things. Like in the machine learning algorithm, we are having input and output. Input is your X, output is your Y. What we can change, we want to drive a equation. We want to create a equation that would be your model for the future, and in that model you will feed different X value. It will give you prediction for the Y value. This is the basically machine learning algorithm we are doing. We having input, we having output. We want to create a algorithm, we want to create a equation. But how we create a best equation? For that we need to put the different values for A and B. How to calculate the different values for A and B? Here we are using this type of calculation, like new value. Initially we start the random values of A and B, and then new values we will going to create with the help of A2 equals to old value minus some learning rate into partial derivative of mean square error with respect to constant. Okay, and about the learning rate, if we take very big value, means your steps is very big. Your steps is very big, it means you can, I'm taking a step, one is here, another is here, so I miss this local minima, and I'm taking very small steps, then what happens? It will take very much time. So we will take some standard values. We don't derivative partial with respect to X and Y because we are working with the mean square error equation, not working with this equation. This we are going to create. We need to put the different combination of A and B. This is mean square equation. What is the mean square error? Actual value minus predicted value. How you are getting the predicted value? With the help of this equation. And then square divided by n. So what the things we can change in this algorithm A and B? Okay? Dheeraj, I think this should be clear. Why didn't you differentiate partially with respect to X and Y? Because Y is we are going to predict. We just want to create an equation. Like yesterday, I have created one algorithm with the help of sklearn, a model. I have created a model, my model. And then I have checked what the coefficient value it's picking, coefficient value and intercept value. So basically it's taking some coefficient value and intercept value, and if I'll write, I just want to predict for if somebody is having years of experience 6, I just want to predict salary. So I'll put in the equation this coefficient into 6 plus intercept. Then I'll get the prediction whatever my model is giving me. So basically my model is creating this equation. Now I need to check how my model is calculating this intercept value and this coefficient value and this intercept value. So I just want to calculate these values by using some other methods. Okay. So basically here I'll write some more code. Okay. I'll write the code for the gradient descent. Let me show you how you can write the code for the gradient descent. Okay. So here I'll import numpy as np, and then I'll write here import matplotlib dot pyplot as plt. Okay, and then I'll define a function. I'll create my own function for the gradient. Initial value, I need to take some initial value for a and b. So initially I'm taking for a value, for a 0 and for b 0. Initial value I'm taking a and b is 0, and learning rate I'm taking some value like 0.001, something like this. Okay, and then I'll take some array like x in numpy array and p dot array, a simple values I'm taking here in numpy array like 1, 2, 3, 4, 5. In numpy array. Okay, and y I'm taking here y equals to, I just want to tell you the math behind these algorithms. Okay, and some y value I'm getting like, you can write here something, equation is y equals to 3x plus 2, something like this. So if my equation is this, then 3 plus 2 is 5, and then 6 plus 2 is 8, and 6 plus 2 is 8, 9 plus 2 is 11, and then third 4, 14, and then 5 is 17, something like this. I'll get the y value using this equation. Okay, now I'll define some, you can define the function or you can write there directly. Okay, so simply I'll plot plt dot scatter. First I'll show you the data set. Okay, x comma y comma color I can give you red, and let me show this plot. These are the simple points I'm plotting, simple points. Now what I can do here, I can write a loop, like how many times I just want to change the values for a and b. So I just want to change values for a and b for 100 times. Okay, so I in range 100. Okay, and every time I'll write my equation like y predict equals to a into x plus b. This is simple equation. And then what I will plot here, I'll plot plt dot, every possible line I just want to plot. Okay, x comma y underscore predict, x comma y underscore predict, and color I can give any, otherwise I can leave it. Simple plot. Now I just want to update the values for a and b. Okay, so for updating the value for a and b, what I can do? Updating the values for a and b, what I need to change? I need to calculate first the partial derivative with respect to a and with respect to b of mean square error, and then I need to calculate, I need to use the learning rate and update the value for a equals to a minus learning rate into partial derivative. So here I'll write like this. Partial derivative of a. Partial derivative of a if you can see in the last equation what I have written, minus 2 by n, okay, into sum, and inside the braces I can write x into y minus y predict, right? X into y minus y predict. This is derivative with respect to a, and similarly derivative with respect to b. So you can write y derivative equals to minus 2 of n into sum y minus y predict, right? Am I writing correct? And then I'll update the value for a and b. So new value for a equals to a into a minus some rate, I need to write here, rate I have written, rate into this partial derivative a d, okay, and similarly for b equals to b minus rate into yd, okay, and let me run this code now. Yeah, n is not defined. N is, what is the n? N is length of x. N is total number of points. How many points we are having? 5 points. Now you can see we are getting lots of lines. We want base fit line. We can also print the values for this. Like predicted value you can print. You can print value for A and B or I. A and B initially value is 0, 0. Then we updated the values for A and B. Like this, every iteration we are getting the values. We also see the mean square error also. Okay? How the mean square error? We can print the mean square error also. Okay, so how we can print the mean square error? We can write the equation like this. Here we can put cost equals to inside the braces 1 divided by n, okay, into sum, and then you can put like we need to use some value power of 2. Let me write first, I'll explain it. For value in y minus y underscore predict. Equation I am writing in the mathematical form only. And you can print cost also. I hope this will work. One, two. It's a printing cost or not? Okay. Comma cost. And you can see here the cost. Initially, we can format this also. Initially, cost is 132, then 126, then 120. It's a decreasing. 80, 90, 82, and if I'll scroll down, it's a decreasing. So what we are getting the value? For A we are getting something near to 2.7 and for B we are getting 0.78 and error is 4 point something. What we want for A is something 5. For A is we want something near about the 3. It was 3 and plus 2. For A we want 3 and for B we want 2. So we need to change the parameters accordingly. We can change the learning rate. We can increase the iteration also. Okay. So here in place of 100 iteration I can put 1000 iterations. But what the basically cost is decreasing. Here also you can see if cost is decreasing then we are going in the positive direction. And you can see cost is 0.109 and here my A value is near to 3 and B value is something 1.2. So B value is near to 2 and A value is near to 3. Okay. So basically I'm converging my model. Guys, can you please tell me, are you getting the things? Whatever I told you in the theoretical part, I tried to implement that thing in the mathematical part also. So can you please tell me in the chat window, are you getting the things? Everything is clear till now? We can change learning rate also. I can put some small learning rate. Okay, I can change iterations also. But what I need to do, I need to check out the error. Error should be in the decreasing order. Yes, we are having sklearn also. We can do with the help of sklearn. Overall, in the every algorithm, we are going to use the sklearn. I just want to tell you how the math is working, how the math behind the sklearn, how sklearn is working. I'll tell you one more time. Don't worry. Okay. So basically, what I'm doing here. Whatever I have written in the theory part, 2 equations I am following here, mean square error. This equation 1 divided by n summation y of I minus a of xi plus b square. Then I am doing the partial differentiation of MSE with respect to a and with respect to b, and then I am updating the values for a and b. New values for a would be a equals to a minus rate into this derivative, and for b equals to b minus rate into derivative with respect to b. These 4 equations I am putting in the mathematical thing. You don't need to write these things. These are the basically simple things. And if you are appearing in some interviews, the people always ask how we are calculating the mean square error, how we are changing the value for A and B, how we are doing all these things. So these mathematical things you should know. What is the learning rate, what is the coefficient, and how mean square error is varying with respect to A and B. Yes, we can plot the graph between mean square error and A and mean square error and B. That is the graph every time I shown you. This is the graph between mean square error and A. It's always in the U shape. Always when we increase the value for A, it will decrease the mean square error, and at some point we just want to get that point local minima. At some point we just want minimum error. Yes, we can plot. This is 3D graph. You can see somewhere over the Google. Cost versus gradient 3D plot. MSC with coefficients. Because 3D plot will give you more proper structure. I don't know, there would be some images. Let me check it out. Yes, this one I want. I just want to show you this one. This plot you can see control. Okay, this plot basically we want. Here you can see mean square cost MSC with respect to M. You can say A. This is slop and this is intercept. And this graph is in U shape. You are taking the starting value for the M, some value, and for B, error is maximum. When you are decreasing the values for M and B, increasing the value for M and B, mean square error is decreasing. Okay? Same thing. So what we have taken here, you can relate, this is the mathematical thing, and you can relate with this CSV file also. You can write the same thing here. Let me come to here. In place of X and Y, you can put your data and you can use this. And simply put this into a function. That would be more better. Like, let me define this. I'll put, let me check it out, Control X and Control V, and here I'll define a function def gradient. Okay, and inside this I'm passing X and Y and colon, and these things I need to shift. And I can call this function wherever I need this function. Okay, and I can stop like iteration. I'm taking lots of iterations. Like in place of 1000, I can take 1 lakh iteration also, and I can stop this somewhere my cost is near to the previous cost. So I can use the isClose function from the math. So in the math there is a function called isClose. So I can define here the cost, like before this loop I can write like this also, something cost old equals to 0, and then I can update the cost. A and B. After updating A and B, I can put more conditions. If math dot is close, here I can check coast, comma, coast underscore alt. If they are equals, then I can break the loop. And this coast old, I will assign the new coast. Okay, so something like this you can do. And this will return you, this is a function, so this will return you new values for A and B. And you can use this into your data file. Let me try this. This is simple thing, A and B, X and Y, and I can call this function here like df equals to something pd dot read underscore csv. Okay, and here I need to read the file. So let me upload first file. Which file? Salaries. We were using, I think, salaries. Salaries dot csv. And this salary is having 2 columns. So I need to change like x equals to np dot array, numpy array I need to convert, and df of, I don't remember the column name, salary, let me print, let me check it out. Years of experience. No, this is the different file. Delete this file. Which file we have used yesterday? I think maybe in downloads. Salary data. Okay. And this salary data having 2 things. Years of experience. Yes. Salary data. Okay. This is small s. And then here I need to put, let me open this here. This one. You can check the column name. I just want to do the things quickly, so that's why I'm copying. And second is y equals to, another way yesterday we have tried. Now I'm converting directly df and then salary. I think this is the second column. Salary, right? And so let me close this. This is y, x and y, and now I can call my function. This will give you m comma b equals to something gradient, and inside this function I can pass x comma y. Okay, and let me run this code. PD is not defined. I think pandas I have not imported. Import, you can do like this. Pandas is PD. And let me run this now. Where I have used math, I need to write the import math. Okay, almost we have done. There are some other coast old spelling mistake. Here, where is COST? Now we are getting something. We can print M and B. Print M comma B. So it's giving M value is something 9547 and B value is 1520. You can optimize these values. Okay? You can optimize these things. Basically, I'm telling you the way how you can try this. I think now everything is clear. Guys, can you please tell me confirmation in the chat window? Are you getting the things? Today's class is nothing new. I just want to tell you some maths behind the linear regression. Okay? So basically you can implement like this, and another way we have used sklearn. Sklearn you already know. We have implemented the sklearn. So sklearn thing you should clear. Simply you can write the, you can simply read the data, create the linear regression model using the linear regression, importing from the linear model, and then you can fit your data x and y and you can get the coefficients. And you can compare the coefficients. Okay? Hopefully everything is clear. No, I just don't want to teach the math for every algorithm, but wherever it is required, I'll tell the things. Maybe you can see my code. Let me share this column because this is very important. But guys, please don't edit it, just view this. Okay, I'm sending in the chat window. Okay? This is little bit complicated, that's why I have shared the code. I don't believe to share the code with you guys because if I share the code, you don't try. Some people even don't try. So just try to do the things by yourself, little bit. Yes, you can plot the different lines here. This is the base fit line I'm getting, I think. What is this plot? I don't know. Okay guys, clear everything? Next thing is, I can tell you how we can save a model. Like we have created a model, we can save a model. Okay, so how to save a model? This is the simple example we have done. Like we are reading the salary data and we have created our own model. Now I just want to tell you, I can, like wherever we are having very big data set, we don't need to train the model again and again. We can save our model, pre-trained model. Training will take lots of time. Okay, like here, let me tell you one thing. model save. We can save a model. We are doing training of a model while we are creating an algorithm. So sometimes what happens, we have taken very small example, this is having very less data. But what happens, sometimes you are having lakhs of records. Okay, so training is taking time. And we don't want to waste our time again and again. Once we train our model, we can save our model. How you can save your model? There are the different libraries to saving your model. Okay, one of them is Joblib and one of them is Pickle. So I'll tell you both the libraries how we can save our pre-trained model that we can use in a future wherever we need it. We don't need to train again and again. We can skip the training part. Okay, you can use a pre-trained model, like I can train a model, I can save a model, I can share my model with you guys. You can use that model. You can just put your X and it will give you the Y. X and model will give you the Y. This is my model. So this model I'll save in a file. Getting what I just want to tell you? I just want to tell you how we can save our model. Okay, so basically I just want to save my model with the help of Pickle and Joblib. Same example I'm using that I have used yesterday. Okay, so I'm running this code again. I'm reading dataset, certain statistics. Okay, I'm running this quickly. Splitting dataset and then creating a simple linear model. Till now, and I can do the prediction part. Coefficient, intercept, scatter plot, all these things. Now I'm going to put certain code part here. Okay, so some blocks I have inserted here. Okay, some text, save a model. Okay, and this is for gradient part. How to save a model? Saving a model, I'll use Joblib and Pickle. Two libraries, two things I'm having here. One is the Joblib and another is Pickle. Okay, so first I'll use Pickle. Okay, in the Pickle, I need to import the Pickle package from the Python. Import Pickle, and then you can write like this. You can open a file, and then inside a file you will put your model. So with open, okay, and I can give any name. Model save Pickle. Okay, I'm giving this name, and I need to open this file in write mode and in binary format. So that's why I'm using here W and B. W for write mode and B for bytes. As file. In the file handling, I'll tell you these things also. So I'm just opening a file. Here I'm giving a new name. It will create a new file, and then inside this file we will put some byte code. Okay, so from the pickle dot, there is a function called dump. And what is my model name that I have created? My model is, I think, my model. This my model I need to save. I trained this model, my model. Okay, so inside the dump I'll put name of model, and then I need to give the, where I need to put inside this file. It will create a file named this, and this is I'm representing with the variable called file, and pickle.dump my model. This my model I'm going to put inside this file. Okay, and let me run this, and it should create here a file, model save underscore pickle. This is my model, created a model. You can open this model, there would be some binary code. Okay, I don't need to understand this. So basically I have created a file, model save underscore pickle, and I have put my model inside this. Now I can use this. I can load my model and I can do the prediction with the help of this. Okay, so let me load model and prediction. Okay guys, so here I'll open this file with open, what I need to give here, name of the file. What is the name of the file? Model save underscore pickle. Okay, and then we need to put here read bytes as file. Okay, and here new model equals to pickle dot load, and inside this I need to put name of the file. This will load my model, and now with the help of this new model I can do the prediction. I can check out like new model dot predict. Okay, and somebody having salary years of experience like 5, what would be the salary? It will give you salary something 71,000. You can check either coefficients also. New model, okay, new model dot coefficient. You can check the coefficient. This is the same coefficient. Okay, clear? Guys, what I am doing here, I just created a model. How to create a model in the last class I already told you. Okay, so I trained a model. I'm having a trained model, and that I just want to save. For saving the model, I'm using here pickle, import pickle, and you can create a file. Inside the file you can put your model. So my model is already trained model, and with the help of pickle.dump function I can save my model inside a file, and that file is created here. You can download this file, you can save to your local disk also, and you can save to your drive also. And then after some time, like after 1 month, 2 months, you can use this model. You need to load the model, open the file, and then pickle.load function, use pickle.load function and load the model, and then you can use this model by doing some prediction. Okay? Okay? Similar thing we can do with another library that I told you, Joblib. We can use the Joblib. Last library, I'll tell you Joblib. Okay? After that, we will end. Don't worry. But one topic we are in between, simple, that is very simple. Joblib is simply like this. We import the Joblib. Okay, and then we will use Joblib is from sklearn. So let me write here Joblib. Similar to Pickle, we can use the Joblib also. When we are having big arrays, we prefer to use Joblib. So from sklearn dot there is some externals. Okay, from externals we need to import Joblib. Okay, and then what we can do, we simply Joblib dot, here we don't need to write the file also, don't need to open the file, dump, and you can put your model name, my model, comma, and here I need to put the name of the file. So I can write model underscore Joblib. I can run this. This will save a model. What name? Model underscore Joblib. Model underscore Joblib. Okay. From sklearn.externals import Joblib. Joblib.dump my model underscore Joblib. You can load the model similar. Joblib.load. Joblib.load. And then you can put like this model, comma, name of the variable. What is the name of the model? Model underscore Joblib. And I can put into new variable my model, or you can say loaded model. And I can use this. What is this? I'm not getting. Yeah, my model. What happened? Model underscore Joblib. Okay. Yeah. For this, I don't need to put here. That was my mistake. I need to give only the name of the file. And now my model I can use for the prediction. That's all. Dump function is for saving and load function is for loading the model. Two functions only. Okay. Difference between those two is generally you can search out this like Joblib sklearn persistence. You can check it out, sklearn persistence, and here you can see it will tell you the difference between those two. Joblib. In the specific cases of sklearn, it may be better to use Joblib replacement of Pickle when we are having bigger arrays, large NumPy arrays. Okay? Basically, we use Joblib when we are having large NumPy arrays. Okay? Yes, dump function is used to write the object to some serializable, to the file. Okay, guys? Yes. So that's all for today's class. I think this is enough. We tried to cover the basic maths behind a algorithm and then how to load a model, how to save a data with a model with the help of Joblib and Pickle, and how the gradient descent works, how you can write a model without the sklearn. Okay. So that's all, guys. We'll see you tomorrow. Today I'm not providing any assignment. What you need to do, whatever I have put it in the last assignment, you need to complete that part only. Like here, online training live classes, you can go to the assignments and the things Where is the assignment? Here. Click for the assignments, and the last assignment. I have provided you the last assignment regarding simple linear regression. You need to do all these things with this data set. Okay? So thank you so much guys for today's class, and we'll see you tomorrow. Okay, bye-bye.